Welcome back to another HVAC-Engineering-Techie training video. Remember, these videos are educational in nature and intended to be a part of your career. Remember that this channel talks about all things HVAC, including engineer design, construction, equipment, systems, tab, controls, efficiency and performance, and a few other subjects from now and then. Remember that today's video is an HVAC evaporative cooler systems. Now, these cooler systems are only used in areas that don't have real high humidity, like you wouldn't use these in Florida anywhere, but anywhere else that's dry or high elevation, we use these evaporative coolers because they can cool with very little money. I mean, they don't take much energy. So before we do, remember to become a subscribing member if you're not already. Hit the subscribe button down below. Give me a thumbs up if you like the videos. These free to you, absolutely free, cost you nothing, and no one will bug you. But it's not gathering your information. What it's for is Google uses this information to evaluate these videos, which keeps me on the air, and I'd really appreciate it. All right, let's go look at evaporative coolers. All right, we're going to talk about evap coolers today. Now, evap coolers are units that have a fan, and they have a cooler pad, which actually it wets with water, and as the fan draws the air through the pad, it evaporates the water, cooling the air. And these are used, of course, in areas that don't have real high humidity or areas of high elevation. Now, basically, you're not going to use these in southern Florida because it won't work. What happens is the high humidity defeats the evaporation effect of the water, so they don't get cold. But high elevation, they work well, even in areas that may have, like the Northeast, which may have higher humidities, but high elevation will work because the natural part of elevation is change in humidity, and the humidity goes down. So they will work up there. And the areas that are really, really humid, like Florida, don't have any high areas anyway, so you're going to use them there. So we have pad-type coolers. This happens to be a side draft cooler, so it has a centrifugal fan. It has a pan on the bottom where there's water, and they have these pads on the sides of the coolers, and the little pumps the water up and over the pads, and the fan goes through, and that's what cools it. They can be roof mounted, they can be downdraft, they can be side draft. They can be 1,800 to 24,000 CFM on standard units that you would purchase as a package unit. However, there's some people that make much bigger ones, but they're actually custom units. I've seen them as high as 50,000 CFM, but they're special. They're not. You wouldn't buy them as a packaged manufactured system. Be a special deal. This is a cell deck type cooler, which has cell deck media, which is made of a structural material, and actually it looks like a honeycomb. And that honeycomb gets wet, and then it draws the air through, it evaporates just like the other. The only difference between this one is a cell deck is only on one side, where the other coolers, these could be on all sides that didn't have an air opening. So these are a little bit more restrictive on flow. They do a little better job at evaporative, and they're a little better unit, but they are smaller. So this is a single stage wet cooler. They do have two-stage cooler with a dry and a wet side, and we'll talk about that in a second. They're 1,800 to 30,000, can get them a little larger. Now this is kind of something that's interesting. It tells you about the cooler effectiveness. So here, if you have the outside air humidity is anywhere between here and the outside air temperature is this, then this is the temperature group of the supply air. So if you have an outside air temperature of 85 degrees, and you're in a humidity area from 30 at 30% outside air humidity, this cooler will actually do a 15-degree drop. So that's not too bad, even though you've got a high humidity. 30 is not high, but if you're at 50, you see it only has 11-degree drops, just a little bit less. Well, if you go down here and you have 100 degrees outside air temp, and you have 5% humidity, you get a 29 temperature drop. So you see, where I live in the desert, yeah, we have 5% humidity, so it can be low. So this kind of gives you an idea of the effectiveness, how hot it is outside, and how much you can get one of these to actually work. So they're very effective. The lower the humidity is, and you see, if you have 100 degrees outside and you have 35%, it still does a 20-degree drop, which is about a cooling coil. So they can be very effective. 11 degrees is not very effective. So if you're up here at 50% humidity, they're not going to do much for you. Now here's a single stage side draft like I talked about. Here's the fan motor, and then we have a cooler pump. We have a drain pan down here, and this drain pan has a water level, has a water level controller on it, and it takes the water, pumps it up, and runs it over the fill. Now we balance this water flow so that the fill is all effectively wet, and then the fan draws it, and it will, if you keep it that way where it's all wetted most of the time it's running, it won't scale as bad. If you have it where it gets wet, dry, wet, dry, wet, dry, it'll scale really bad. The other thing with evap coolers, their problem is maintenance. Maintenance is very high on them. So what we try to do is we try to dump this water every once in a while and bleed it, so we keep the concentration out of this span. Because as it evaporates the water coming back still has all the solids on it the other water had. So this pan begins to grow in solids, and it'll get real high. So what we have is normally we'll drain every so minutes in a day. We'll drain this down when it's pumping, so it fills up new water, and then we stop it. So they call it green machines, but the one I had I don't have it anymore, but it would bleed about 5 minutes for every 4 hours of operation. And then the next thing I went to is I put a discharge valve on this discharge pipe, and I ran that with my lawn sprinkler controller. So I would come on and run it 5 minutes every day or 10 minutes every day, and it drained half this pan and fill it back up. So that they do work fine. They cool the outside by evaporation of the water over the cooling pads. Single stage downdraft, same thing, except it goes down. The thing about this is that you have a lot more pad area than have the other one. You need a water blow down, which I just talked about. Typical control sequences unit should be enabled anytime the system is in the occupied mode on a commercial building. First stage cooling should be the fan operation. The second stage cooling should be the circulation pump. Monitor the room temperature, fan, and pump station status. And that's a standard evap cooler. Now this is a two-stage cooler, and this is a cell deck type cooler. Not all cell decks are two-stage. And two stages gets you a little bit better temperature because it has two evaporative stages. The first stage is what we call a dry stage, whereas the air goes through the inner tubes, these tubes going through. And on the outside of these tubes is a net material, kind of a wicking material. And it has a water pan and a pump, and it pumps water over the outside, the cloth on the outside of these tubes. And this is a fan that takes the outside air and blows it through, so it's cooling. And what you're doing is you're dropping the temperature of this air without adding any humidity. So it's the first stage is sensible cooling only, no latent cooling. That makes this air drop down 10 to 12 degrees more than it would have. So now all of a sudden, this wet pad, which is a cell deck material, sees a lot colder air than it normally would. So this two-stage coolers produce much colder air than a single-stage cooler. And of course, this cell deck is operating like an air washer. It has a pan, takes the water, runs it over there, and this fan, inducing the air, is cooled by that moisture. So we have both dry bulb and wet bulb cooling going on within this two-stage cooler. First stage is dry cooler. Second stage is standard wet cooler. Dry cooler adds approximately 35 to 40% higher temperature drop depending on the humidity level. So that can be important. There was a manufacturer in Colorado called the Colorado Cooler, and he did this like 10 times. So he had these dry coolers, and they were kind of staged where the water in coming off of this went to the next one, went to the next one, went to the next one. And he could it was a very complicated cooler, but he could get very close to air conditioning temperatures. And the only problem with the unit, it was susceptible to clogging because it had very small water channels. But it did work. It was interesting. Typical sequence for this, the unit should be enabled anytime the system is in the occupied mode. First stage cooling shall be fan operation. Second stage cooling shall be the dry cooler with circulating pump. And third stage cooling shall be the wet cooler circulation pump. Now, I mentioned at high altitude, these may work very well, maybe too well. I had a job in Flagstaff, which is a 7,000-foot elevation, and it's in the west, so it's a little dry anyway. And when you would turn that air washer on, that unit would drop 25 to 30 degrees display immediately, just bam. So we had to modulate this water because it was too much of a drop. It would shock the system. It was a variable volume system, and just boy, me to get 30-degree colder air, everything would go into shock. So we had to slow that way down. It was just too erratic, and you never wouldn't think an evap cooler would do that much, but boy, it was cold air when it came out of there because it was real high altitude, and that was return air of the system, so it wasn't that cold. So we had very low humidity at 80 degrees, and it could take that air right down to leaving coil temperature off of a chill water system. All right, this is an air washer, which I was just talking about, which is a regular air handling unit, and it has a evap cooler pad in here, which is normally cell deck material. It has a pump and a pan, and it pumps water over it. Then the air goes to a cooling coil. Now, this is interesting. So what happens is this coil ends up taking a lot of dry bulb temperature sensible out and adds latent heat to it, so it has more latent in it. And if that latent is too high, this cooling coil will actually take it out. But a lot of times this gets it up because the design standard for air conditioning is that this coming off the coil is saturated, and what we want is 50% in the room. So if it may not even take it. So this may already provide enough moisture to have 50% in the room, and that works fine. So this is an air handling unit, air washer, evaporator, cooler section of the air unit. Typical sequence is the unit should be enabled anytime the system is in the occupied mode. First stage cooling should be the fan operation. Second stage cooling should be the circulation pump for the air washer. And the third stage should be the cooling coil from the air conditioning unit. Monitor the room temperature, pump and supply. So basically this can have a lot of stage of cooling. Again, first stage is fan, second stage is air washer, and third stage is the actual AC unit. It's short and painless one, but the evap coolers are used especially in makeup air systems. If you looked at the other ones on makeup air outside air units, we use them a lot in makeup air systems. So I hope you got something out of that. I appreciate you being a subscribing member. It really helps me. Thank you. Have a great day, and I'll catch you on the next one. Thanks.